Okay, so hello everyone, welcome to Code Enzyme. In this video, let's analyze Starters 133 Codechef Div 2. Okay, so I think let's just start. So I will be solving all these problems one by one, and if the video gets too long, then I will stop. Okay, so let's see the first problem. We have a maximum alternating sum. Okay. Okay, so let's first read the problem statement. The alternating sum of an array n is defined as this value, and you are given an array of length n. You can rearrange this array however you like. Find the maximum possible value of the alternating sum after arrangement. So we can arrange it. So okay. So if we have summation of ai, then it will become a1 minus a2, right? Plus a3, and it goes on till an minus 1 to the power n, right? I think, yeah, n plus 1. So what is happening is we have a1 plus a2, uh, a1 plus a3 plus a5. So all the odd terms, odd places will get a plus value, and minus all the even places, a1 plus a2 plus a4 plus a6 and so on. Okay, so what I can basically do is first I can sort the array, and if the number of elements are even, then I can place the bigger elements on this place and the smaller elements on this place to maximize the sum. Okay, so okay, let's just code that. So we have the input format is first we have an integer n, and then we have an array. Okay, so now that we have this array, what can we do? Let's first take the input, and this is the expected output. So first let's sort the array. So a dot begin comma a dot end. First this array is sorted. Now let's say sum at odd places equals to 0 and sum at even places equals to 0. Okay, then the first n by 2 elements, wait a second, I will come. Okay, sorry about that. Where was I was at yeah. So first n by 2 elements will go to sum odd. So sum odd plus equals to a of n, right? The top elements I will go to this place, and then for I in range from n by 2 to n, they will go to sum at the even places. I think I did something wrong. There should be I mean, since it is sorted in ascending order, either I can sort it in reverse order, or I can say like some even should be here and some odd should be here, I think. Yeah, and in the end I can simply see out some even, some odd minus some even, right? Okay, so we are getting this answer, and okay, since I have converted into long, I don't think this will give any errors. Let's submit this and see if it works. Okay. Okay. Okay, so that gives us a correct answer. Let's move on to the next problem, that is powered parameters. So we are given an array A containing n integers, and we need to count the number of ordered pairs I and j such that this ai to the power j is less than equals to j. Okay. So we have powers, and what are the constraints? ai is going till 10 to the power 9, and ai can also be 1, right? Okay, So if you have 2, 3, 4, so you have 2, 3, 4 as an array, the indexes are 1, 2, and 3. So if I have index 1, then I need to find the indices such that the 2 to the power something, like 2 to the power 2 is not less than 3. So this will give us, this is a no-no, right? I don't need to care about this. I mean, wait a second. So if this is a 2, then 10 to the power 9 is 2 to the power how much? So basically, if I say log 2 of 10, 9 times, what is this? So almost 30, right? Yeah. So what I can do is I just need to check for the first 30 indices only, because after that the power will exceed, obviously. So we can just do it brute force, and I can say that this even if I check for the first 30 indices till the power exceeds, this will not go above 32n. So it is almost like big O of 32n, which is approximately equal to big O of n log n time. Okay, so for every index just check for the first 32 elements or so, not more than 32 elements, and we will be good to go, because because AI, what is AI? Just a second, what is AI? AI is going from 1 to 10 to the power 9. So I think if it is 1, wait a second, if it is 1, then if AI equals 1, that means every element is whatever I do a power, then I simply need to add n to the answer, because every other element will be, I mean, no matter what power I give it to, the answer will not change. Every element will be less than equal to that power, right? So that is a special case if AI equals to 1, otherwise we are good to go. So let's copy the input and let's copy the output. Okay, so first case is we have an integer n, and n c in n, vector int a of n for I c in a of I, right? Okay, so now that we have the array, we need to calculate the answer. So let's say answer equals to 0, and for I in range this, what do we have first? Like if my a of I equals 1, then I don't need to do anything, just simply add n to the answer, right? Otherwise, let's say my currently the value is a of I. Okay, now starting from index 0, like for let's run another for loop for j in range this. So 2 to the power j plus 1, because in the question the indexing is 1 based, not 0 based. So what I can do is current, okay, let's start with 1 only, equals to current times j. Okay, not j, a of I. And if this current is greater than 1 e9, then obviously I need to break out of the loop, because no element in this array is greater than 1 e9. Now if a of j is less than current, then I can say answer plus plus, right? Yeah, and also this value will never, this loop will not, never run for more than 32 times. Why? Because 2 to the power 32 is greater than 1e9, so it will obviously break before this happens. So that is my claim, and now after this I can simply see out answer, I think. Yeah, so let's run this. Okay, we're getting 8, 12 and 18, which is wrong. Why is that? Okay, let's try to debug the code. First we have an integer n, then answer. So 1, 2, 3, 4, why are we getting an 8? mm, and current equals to 1. For j in this, current equals to current times a of I, and if current is greater than 1 e9, then we break. If a of I is greater less than equals to current, then answer plus plus. Okay, let's run this again. And why is this happening? Now we're getting a 9, which is even worse. Why is that? Let's debug the curve value and also debug the a of I value. Okay, so first my a of I was 2, then for 2 I think let's also debug the answer very well. Yeah, so answer was 1, then curve was 4. Why did the answer increase? I think I reversed the condition, curve less than equals to a of j. So now we are getting 1, 4 and 14, which is correct. So yeah, that was the mistake, and I think this should work now. Yeah, so let's try to submit this and see if it is working. So that gives us a correct answer. Now let's move on to the next problem, that is ABC conjecture 3. Sorry. Okay, so let's first read the problem statement. You are given a string S of length n containing only the characters A, B and C. In one move you can modify S as follows. Choose 3 indices like this, A, B and C, such that Si equals to A, Sj equals to B and Sk equals to C. That is, choose some subsequence of S that is equals to ABC. Then delete either A or C from S, that is either index I or index K. Note that this reduces the length of S by 1. For example, if this is the string, then you can choose I equals to 4 and J equals to 6, then K equals to 8. Okay, and we need to remove wait a second, I will just come back. Okay, sorry about that. Now someone came now. So okay, so we have this, and now we have okay, so we need to find the minimum number of moves such that S can be made on S, that such that it is impossible to perform any further moves on the resulting string. Okay, now we can either remove A or C from it. We can't remove the B's, so B will stay in the string. I think this is very similar to the previous problems, ABC conjecture, and yeah, I think there was a very similar problem. It was not exactly this problem, but I mean, we had strings of A, B, B, and C, 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 then B, then C, 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 then let's say some A's, then B, and then again some C's. Okay, so if we have this, then this A can be paired with either this B or this B or this B, any one of them, right? So like if we have this, then what is the minimum number of moves that we can make? So this A can be paired with this B and this C, right? So what I can do is let's make this pair. Let's make this pair, and let's also create some pairs like this, and let's also create some pairs like this. So since we can make 4 pairs, like we can make 4 subsequences, like distinct subsequences, right? Distinct A and C pairs. I mean, I'm not calculating every pair, like this is not the number of combinations that I can make. Like if I am choosing this A and this C, I'm not choosing this C again, right? If I chose this C, then I won't choose this C again for the other A. So I'm just checking how many distinct A's and C I can make, right? And I think that will be the answer. um, because what I can do is I can simply remove the a's, whichever is a smaller number, and once they are all gone, then there is no possible way to make it. Yeah. So how can we find, like how can we find these pairs? So what I can do is I can, hmm, first of all, what I can do is I can make, like for every a I can calculate, like okay, this a is coming before, let's give this number a 1, 2 and 3. Okay, so for this a, this is has index 1, like it is coming before the first b. Okay, okay, now this a has index 3, so I'm assigning these values and indexes, like at how at before which b this a is coming, this c is coming before second, second, this c is coming before, these values don't really matter. Okay, this c is coming before third b. Okay, and this key is coming up before the fourth c or whatever that is. Now obviously this a will be paired up with some c which has a index greater than this one, right? So I can pair these two because they have index same. Now I can also pair these two, but now I've run out of a's and this c will be skipped, and so I've got two pairs from here. And now even if this was switched, then I can't pair these two. Okay, so that is the main logic behind this. And yeah, okay, so what we can do is, let's first copy the input format and also the output. Okay, and what is the input? Let's first take the integer n, string s, cns. Okay, and now let's have a vector a and c, right? Yeah, and let's have an index value of 1 for I in range this. If now we have three cases, s of I equals an a, then I will do something. Else if s of I equals a b, then I will do something. And else case, else it will be c, right? So a dot pushback, push back the index value, otherwise I will say index plus plus, and c dot pushback the index value, right? So we have these three, and once these are with me, what I can do is, let's run another loop till a dot what size. So for every a I am going to assign a c to it. Okay, and now let's have an index j which is initially 0, while j is less than c dot size, and uh, a of I is greater than or equal to c of I, c of j. Till that point I'm going to do j plus plus. Okay, like obviously I want to find the c which is occurring just after the b that this a of I is occurring. Okay, like that. Now after this loop, if j is less than c dot size, and and what a of I is mm, less than c of j, then I will say let's also have the answer variable, answer plus plus and j plus plus, because I'm not going to use this j once more, right? So and after this I can simply see out my answer. So these are the distinct subsequences I can make, and this is the answer I'm getting. Okay, so let's try to submit it and see if it is working. Okay, so that gave us a correct answer. Let's move on to the next problem. Wait a second, let me shut the door. Okay, actually my voice is cracking, I know, because I have a little bit of cold right now. Okay. I mean, this was an easy problem. I don't know why it has only 279 submissions, but yeah, and the submission and the accuracy rate is also very low. I'm not sure why, but yeah. Okay, so that gives us a correct answer. Let's move on to the next problem. That is too far for comfort. Okay, is the audio getting recorded? Yeah. Okay, and the recording is on. Okay, so it has already been 20 minutes. Let's finish it fast. Okay, we have an array. Okay, so this is in there are easy and hard versions for this problem. So why did they even split it? They could have just distributed the subtask for it. I'm not sure. Are they different or the same? Okay, let's just read these two problems first. You are given an array A of length m and it is said to be prefix balanced under the following conditions. SI denotes the set of all elements that appear in A. Okay, and SA can be between 1 and m. FI denotes the number of times x occurs among some prefix. Okay, and this denotes the frequency of x in prefix. Uh, so what is the difference between a hard version? Okay, so it is slightly different. An extension to this problem, and you are given an array A of length m, and it is said to be prefix balanced under these following conditions. Okay, so an array is missing. The first problem, we can choose the elements independently, and we are free to do so. Okay, so I think this will be a purely mathematics question. Like I think the tags are combinatorics. Yeah, so this is a purely combinatorics question. I think this will be easy. So let's see it. Okay, so you are given an array. An array. We are not given an array. It is said to be prefix balanced if the number of times an element occurs. If, let's say we have, let's say we are given an array. Okay, I mean we decide we want to make an array. Okay, and in any prefix like a1 to ai. Okay, if we have two elements x and y, then f of x minus f of y, mod value of this should be less than equals to 1. What does this mean? Like if I have x, um, can I have x and y? I mean for this prefix it is correct, but for this prefix uh, it is not. So this is a no. What I need to have is xy and xy only. Xy, and in here I can either have xy or yx, right? Yeah. What if we have xyz? What if I decide like I will take three elements x, y, and z. Then I can have a combination of x, y, and z. These three can be done in 3 factorial. Then we can have another block of x, y, and z and arrange them in 3 factorial ways and so on. Like till there are n elements, right? Okay. I think I get it now. So if we have like n elements, we have n elements. Let's see from the sample disk case. So I think we are given n and m, so there are only 10 choices. So that is why the answer is this. If we have 3 and 4, so if we have n equals to 3 and m equals to 4, like okay, if I say my if I say only one element is occurring in the whole array, then I have 4 choices, right? Like that same a will occur here, so I have 4 choices for this one. Like if the number of elements that are occurring in this array, let's say that is equals to x, then I have so let's say x is equals to number of or I think they already noted it. So if it that is SA, right? So let's say SA is equals to number of elements occurring in this array. Okay, so I mean, I let's say if SA equals to 1, then we have m possible ways, right? So every element is equal, so I can choose MC1, which is equals to m. So there are m ways. Okay, now what if we have SA equals to 2? So first of all, the choices I have is MC2. Out of m, from 1 to m, I can choose any two elements. And then since n is equals to 3, I mean, so we have 1, 2, and 3. Like I have selected these two elements, so let the elements be x and y. So from the for the first block, I can choose x. I can put them like this, or I can put them like this. There are two factorial ways, right? And in here I can still choose these two elements, so MC2. But I can only put it in one way, so 1 factorial. Yeah. Okay. Okay. So I think that is good. What else? Like let me just add a page. If my SA equals to 3, then I can choose from these m elements. I can choose 3 of these elements, and I can put them in 3 factorial ways. Yeah. So wait a second, someone is calling. I will just come back in a second. Hello. Hello, hello. Okay, so let's continue. Where was I? Hmm. Okay. So I think it is like we are given n and m. Okay. So first thing I need to decide is what are my number of elements, like SA. What is the number of elements that are occurring in this? Like SA can go from 1 to I think m, right? I can choose either one element till m element, anything. Uh, what are my constraints right now? 10 to the power 5. So we have to solve it in big O of n or m time, strictly. Okay. Hmm. Okay. So let's say if my first thing I need to do is set this SA. Let's call it k right now. So first thing I can do is select some k elements for some fixed value of k. I can select some k. So okay, these many k elements are occurring in my array right now. Okay, once I have this, I can divide this n, like I have n positions, right, into some k blocks, like one block, two block, k size blocks. Okay, like that. So what I will have is some blocks will be complete, and the last block I'm not sure if it will be complete or not, right? So let's call this the number of times this is occurring as y. So simply my y will be equals to n by k. Okay, so I'm taking the GIF of this. So now what will happen is each of these blocks can be rearranged in n factorial ways, right? K factorial ways, because they are k size blocks. So I can say k factorial for this block and k factorial for this block till y times, right? So this will be equals to k factorial to the power of y, right? Or I can say to the power of n by k, right? Let me just remove this. So these are the complete blocks that I have. Uh, Now, what about the last block? For the last block, I have this is like n mod k, uh, right? If it is n mod k equals to 2, then I will have two values left at the last. So for this block, the choices are the same. So this is good. But now, out of this k choices, I have to choose these many values. So I can say k, c, the n mod k value. And now I can rearrange this. So I can say n mod k factorial. Okay, so this is for the first n by k blocks, and this is for the last block. And this k, the size of the uh, what should I say, my k is going from 1 to, I think I can go till m directly. So I think this will be computed in big O of n log n time easily, because both n and m are going till 10 to the power 5, so it doesn't really matter. But yeah, I think this should work. Let's try to code this up very quickly. Ah. So that was purely a mathematics problem. Let's try to code this. And now, if you have any doubts, you can tell me in the comments. I will definitely answer to them. Okay, so first we have int n and m, c n and m. What we need is, like if this is the formula, we need the function for ncr, right? So I think I will have to write it. So if we have int ncr, we need an int n and int r. Now obviously if my r is less than 0, or I mean it won't be less than 0, I'm sure. If n is less than r, then simply return 0. I'm not sure if this will occur, but yeah. Otherwise, I need the factorial values, so let's also have that. So let's say int, let's say constant max n equals to 5 into 10 to the power 5, so 5e5, right? Yeah. So int factorial of max n plus 1, and also let's also have the inverse factorial of max n plus 1. Now I think the mod value is different, it is 9, this value, so let's also change that. Wait a second, I will just come back in a minute. Okay, sorry about that, I have to go so many times, but yeah, now let's continue. Okay, so if I have factorial, now this case might occur. So when this is the case, then I will return a 0. Obviously if my r is equals to, I mean this also doesn't really matter. Let's say return factorial of n times inverse factorial of n minus r times the inverse factorial of what r factorial, right? Now let's take the modulus, just take mod and one more time mod. So this is my ncr function, and obviously to calculate the inverse factorial I will need the modular inverse function. So this is the template from Geeks for Geeks, you can go and check it out. Now I will just do it in int main only. And let's first say factorial of 0 factorial will be equals to 1, and inverse factorial of 0 will be equals to mod inverse of 1, right? And now for I range this from 0 to max n plus 1, I think it was max n, right? Yeah. Let's go from 1, and let's say factorial of I equals to factorial of I minus 1 times I, and take modulus mod, and inverse factorial of I equals to simply mod inverse of factorial of I. Okay, so this will calculate all the factorial and inverse factorial values before running this these solve functions, right? So now I have the factorial and inverse factorial values, and now I just need to run this loop. So what I can say, let's say int answer equals to 0, and for n range 1 to m. Okay, first let's choose the element. So let's say choices, these choices will be equals to ncr of from m. I need to select I choices, like I elements, or I think I denoted with k, so let's actually make it equal to k, not I. So k less than equals to m, and k plus plus mck. Okay, so once we have k choices, I need to find the number of arrangements. Now these arrangements are equal to k factorial to the power n upon k. So let's say int y equals to n by k, Should it be n by k, or okay, let's say int arrangements. The arrangements that I can make, these are equal to k factorial. So factorial of k, and now I need to raise this to a power of n by k, right? And if I do it with a normal power function, it might give me a TLE. So let's use binary exponentiation, binpo. What this does is it calculates the a to the power p in big O of log n time. Okay, so this is something called binary exponentiation if you don't know about it. So you can do some research about it. Okay, so it is simple power function. It just calculate the a to the power b in log n time. Okay, so I will not explain this right now, but yeah. Okay, so what I can do is call it in binpo function n by k times, right? So these are the arrangements for the first n by k blocks. Okay, and after this I need to also account for the last block. So arrangements equals to star equals to multiply, obviously. Now what star equals to, I need to first get this value. So I mean, let's just call this a1 and a2 equals to ncr. Out of this k I need to select n mod k values, right? And once this is here, um, once we have this, now a2 star equals to what, factorial of n mod k, factorial. So I can say a2 is equals to a2 times factorial of n mod k, and let's also take the mod value, mod. And now I need to multiply the choices a1 and a2 and add it to the answer. So let's say just let's say answer equals to answer times the choices and take mod. Next I need to multiply the a1 value, this power for the n by k blocks, and next I need to multiply the a2 value and take mod. So I think this should work now. Once this is done, I can simply see out the answer. Let's run this and see if it works. We are getting zeros. Why is that? So why are we getting all the zeros? We have factorials. 0 factorial is 1, mod inverse 1, um, I equal to 1 from max n plus 1 I plus plus factorial I factorial. So this is correct. And answer equals to 0, and k equals to 1 to m. The choices is mck. Wait a second. First of all, why are we getting 0 for this case? Let's try to debug this. Debug answer and debug answer. I think because I initialized my answer to 0, it should be 1, right? Yeah. Okay, now we are getting something very big answers. I think because, why is that? I think oh, I think I get it now. Because I need to add this, not multiply this. Okay, so let's say the multiplication of all these values need to be added to the answer and not multiplied to the answer directly. So let's say I think what we can do is let's say answer equals to 0 first of all, and multiply these three values together. So let's just multiply it to a2. So a2 is equals to a2 times a1 and take mod, and then a2 equals to a2 times choices. Sorry about this, a very silly mistake, my bad. Now once this is done, I can simply answer is equals to answer plus a2, and now take mod. Yeah. Okay, we are still getting something wrong. Something is wrong. Choices will be multiplied with this, then multiplied with this. So a2 is equals to a2 times this one, factorial of n mod k. And then should I? No, this is not good. Let's only go till n, maybe then it will work. Yeah. Okay, I think that was wrong. I had to. The summation is wrong. It does not go till m. It goes till n because the block sizes can't be greater than n, right? Yeah. I think this is working. Let's try to submit this. Yeah. So we got a correct answer on the easy version. Let's move on to the next problem. That is, it is the recording on. Yeah. So we are already 40 minutes past, and let's solve this problem. Okay. In the hard version, 2 for easy, it is worth 60 points. So now we have an additional array input A. Okay. I think this will be a. This is a tough problem. 2800 rated. I'm not sure how much time it will take me to solve this, but yeah. Okay, so I think it is a continuation to this problem, so I don't really need to remove and recode everything. So I will continue the code from this part only. Okay. Now we are given an array A of length m, and it is said to be prefixed. Okay, an array is so this part is the same from the last problem. For example, if this array is this, yeah, you are also given an array A of length n. Every element of A lies between 0 and m. Wait a second, let me just come back in a minute. Okay, so someone called now. Actually, I don't really get time to make these videos, but yeah, sometimes when I feel like it, I just make it. Okay. So if you have any doubts, you can put them in the comments. Now, okay. So we are given an array. Okay, so if the prefix of length 3 contains, so that is the same. You are given an array of length n, and so if you have a 0, um, so this is also the same. So you have 3040, and let's just see 3 4. We have 3040. So and the answer is 9 for this one. So we can either place 1 1 and okay. Did I just remove everything? Yeah. So if we have this, right. Um, so first what we did was let S equal to the number of elements occurring in this array. So if we are already given this, then obviously my SA will start from the number of distinct elements in this array, right? And it will go till n. Okay. So first thing I need to do is I need to get the number of distinct elements in this array. That I can either do using a set or a simple visited array. I think a visited array will be better because set has another login time, but yeah. Okay, so we have to go from distinct elements. What else? I mean, if I have something like 3 0 0 3 4 5 and 0 0 0, obviously my k will start from 1 2 3, but k be 4? K can't be 4, right? Because if my block size is equals to 4, then 3 is getting repeated in some block, right? Yeah. So k can't be 4. If k is 4, then I need to skip it. And I also need to prove that this is an n log n time solution. I mean, this was a like for every k, I could compute it in big O of one time, right? But if I have to traverse from like this, then it will take me n by k time. So the summation will look like something like n into 1 by k from 1 to n, and this is approximately equals to big of n log n. I mean, there are various proof for this. You can use some Riemann integration and all to prove this, but I mean, like, I mean, you can skip this. Like, if I have 1 plus 2 plus 1 by 3 plus 1 by 4 and so on. So this can look like 1 plus 1 by 2 plus 1 by 2. Obviously, this is greater. The upper one is greater than this. Plus 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 8 till 8 times, and see if this is equals to 1 plus 1 and all. So you will see the number of terms is basically log n only. Like if you go till 2 to the power k and the last nth element, this is this value has approximately log n terms here. So that is why this series reduces to this is approximately big of log n time solution. But yeah, so what we really need to do is like if we have a lot of spaces, like if we want to make an array of length n, right? And somewhere some places we have a1, then again we have a1, we can have a2, again we have a2 and all. So if my essay is going from 2 to n, you will realize that when we have essay equals to 4, like can essay be 4? 1 2 3 4. So this is a valid one, right? 4 is valid, 5 is also valid, but 1 2 3 4 5 6 is not valid, right? Because in 6 this element is getting repeated. So what we need to do is for every essay we need to quickly identify if it is valid or not. So we have two tasks. One is check for validity, and how do we check for validity? What we really need to check if in every of these blocks that are occurring, is there any element that is non-zero and reoccurring in this or not? So we just need to check for that, and once we have checked it, we also need to get the number of zeros in every block. Like for every block, if there are z zeros, then I mean, okay, so first thing, let's say we already checked for on the validity, so we know that this essay is valid. Okay, now once we know that an essay is valid, we can move to the blocks. So let's say we have a block of k size, okay, and there are some x elements in this block. Okay, so if there are x elements, then from m minus x, I can select k minus x values and put them in these blocks. So these are the choices that I have. Okay, so these are the choices that I have. uh, okay, so these are the choices that I have that are already in this already in my whole array. Okay, that I already have in this whole array. So from these choices I can select k minus x choices. No, not like that, not like this. I'm not sure how to go about this. Wait a second. Okay, this is tough. From m elements I can select like for the whole array I had let's say some distinct elements, there were some distinct elements x, and from these elements, let's say there are z zeros in this. uh, no, the choices that I will have is simply m minus x, c, k minus x, right? So these are the elements that I can choose, and from these choices I can I need to rearrange them in every block. So for every block, let's say if that block has z zeros, so there were z zeros, then k minus z were the spaces, and in these spaces I need to select the uh, like, in these spaces I have to, I think it is like k minus x c uh, z ways to actually do it. And now I can multiply it with z factorial to rearrange them for this block. Yeah, right. Hmm. So the summation, the final summation that I think is like m minus x c k minus x times. There will be another summation for every block. This will run in log n time, which is like for every block, just calculate the number of zeros you have and multiply it with z factorial, like that. Mm, I think this should be k minus x c z, because we have so many elements. And now I need to choose z elements from this and place them in z factorial, and I can rearrange them in z factorial ways. Yeah, okay. So we have this. Now what else? Like I need to, what the task still remains, that I need to check if an element is getting repeated or not. Or how do I calculate the distinct, like if you are given, okay, so this is an advanced problem now. How do I calculate, first task, like if you are given L and R, I need to get the number of distinct elements. Except the zeros. I need to ignore the zeros and I need to get the number of distinct elements in this array. So how will you get it? You can actually do this very easily using prefix sums. I'll just show you how you can do this. So I know how to handle this, but there is one more task. It is how do I check if an element is getting repeated or not? So that is the tough task. Okay. Hmm. So I think this can be done using dynamic programming. Not exactly DP, but something like that. What I can do is I can also maintain a DP array. DP of I equals to the minimum index, such that an element was repeated. Element was repeated, right? So an element can be repeated only in two ways. Either if I have AI, then no elements were repeated and AI got repeated again, or there was some AI and it never got repeated, but there was some AJ and AJ again, and then we have some AI. So in this case, the value should be J, right? Um, the DP array. So initially my DP of n equals to n plus 1 and DP of I equals to minimum of DP of I plus 1, comma, uh, whenever I had seen the element last time. So whenever that, so I am going in reverse order, like that, and whenever I have seen the element last, that will be the value. So that is how I am getting the this. And now I think this will become more clear in the implementation part. So let's try to implement this. Wait a second, let me just drink some water and come. I think my throat is cracking. Okay, so where was I? So let's try to implement this. Um, but I'm not really sure about this one right now. Um, first I'm selecting first I'm selecting from m minus x. I'm selecting k minus x element. What is x? The number of distinct element that I have in this whole array, except zeros. Okay, And now once I have this, mm, once I have this, I need to, I mean, why am I using x here? I think this is wrong. I need to get the number of distinct element in this whole block. Okay, so I need some way to find out the number of distinct element in this whole block, and this can be done using prefix sums. Okay, so I think I will do this first in the prefix sum part. So what do I really don't need right now is I need the answer. My k will go from 1 to n, yes. Now the choices that I have will be m minus half and k and c k minus half, right? And also I don't, so let's say the arrangement is equals to 1 right now. And what is this have value? Have is simply the have is simply the let's just make an array right now for I c in a of I. Okay, and I can put these things in a set. So let's say set int s dot insert a of I, and int have is equals to s dot size, and if s dot find 0 not equals to s dot end. So if we have 0, then I will say have minus minus, right? Okay, so we have this now. We got the number of distinct values in this set. Okay, now that we have the distinct values, I think the choices are pretty clear, and now we can move to the blocks. So I can run a for loop for int l equals to, let's go from position 1 to int l less than n less than equals to n, because I'm going from 1 based indexing, and l plus equals to this k value. Okay, now what I need is first I need to check if this block is valid or not. Now to check this block, I need to find out if some element is occurring in this or not. So what I need is if I can get the minimum value at which like if I'm at l equal to 1. Okay, let me just go to a new page. So if I have some pre-processing, if I'm at some index l, okay, and I need to get the minimum index, if I have some way to find the minimum index such that an element was repeated. If I can compute this, then it is easy for me, because I can go from here to the minimum index, and if this index is greater than the next index, that is r. So let's get the r value, and r equals to what, l plus k minus 1, right? Or will it be l plus k? I think it will be l plus k minus 1, because okay, so because that will be the included value, because if I am at l, l plus 1, l plus 2, so it will be l plus k, l plus 1, yeah, it will be l plus k minus 1. Yeah, so we have r, and if the how should I do this? Let's have two vectors, the next next element, such that the element was repeated, and this will have n plus 1 elements. Let's make it n plus 2, and the initially it will be n plus the value initially the value will be n plus 1. Okay, and will have one more element, the last scene of m plus 1 values, and initially it will be n plus 1 only. Yeah, let's go in reverse direction from I equals to n to I mean, this is correct. No, I think I will go in reverse direction normally. Yeah, So if my a of I, so if the a of I is equals to 0, what then? Then simply next step of I equals to next step of I plus 1, right? Otherwise, otherwise what? Next step of I is equals to minimum of next step of I plus 1, comma, last scene of A of I. I think this should work now. Yeah. So it works like this, and once I do this, I can update my last scene value to I. So what is happening is this is some kind of dynamic programming that I'm calculating this. Obviously, if some element is repeated, it will either be repeated when it occurred again in the front of this array, or there will be some element that occurred in between, right? So that is what I am calculating, at which index the element was repeated. Okay. um, so this will be calculated, and let's make this I plus 1 only now, since we are using one based indexing. So we have this. What I also need, like I can say, if the next rep of L, wait a second, since we are, I think this should be I plus 1 and this should be I plus 2, because we are using one based indexing. I plus 1 and I plus 2, and that is why I had this here. So if I n minus 1, then n plus 1, yeah, I think this should work. Yeah. So if my next step L is uh, greater than R, then we are good. Like this block is perfect, right? Otherwise, the number of arrangement will be equal to 0, and this block is invalid, right? Okay, now if the next repetition is greater than R, then I know that this block has a good number of has no repeated elements, and I just need to calculate the number of arrangements that I can make. Okay, so first of all, what I need is I need to get the number of distinct elements in this range, right? L to R, and that I can do using prefix sums. How? Um, let's have int prefix of n plus 1 comma 0, right? Um, and I also need to make sure that this is one based indexing, so let's just go for n plus 2 for right now. For I in range n, if my a of I is greater than 0, I mean if a of I is greater than 0, then let's say prefix I plus 1 equals 1, and prefix I plus 1 plus equals to prefix I. And now I can simply use the prefix L minus prefix R minus prefix L minus 1 formula to calculate this. Like if you don't understand how this is working, let me just explain this. So let's say if you have 0 0 1 2 3 0 like this. So what I'm making is the prefix value, like right now I don't have any element, then 1, then 2, then 3, then 3, then 3, then 4. So basically this is telling me there are 4 elements from this index to this index. Now if I want to calculate the number of distinct elements in this range, I can subtract this value from this value. So prefix of R minus prefix of L minus 1, this value will give me the number of elements, distinct elements in this range, okay, in this whole range. So that is how prefix sums are working. Now once I have this, now I can get the number of elements, and nums, the number of elements is equals to not here, sorry, sorry about that. Okay, so int number of elements is equals to simply the prefix of R minus prefix of L minus 1. So we have this number. Now let's go back. Okay, so for this I need to calculate the k minus xcz. I also need to get the zeros. So int zeros will be equals to simply r minus l plus 1 minus nums. So these are the zeros, right? Yeah. So we have this. I mean, this value will simply equal to k, so you can also write k only. Doesn't really matter. But yeah, so we have these zeros, and now I need to calculate this c value. So let's say int c is equals to let's say arrangements is equals to ncr of k minus this the number of elements that I have, nums, c zeros, right? And we need to multiply it with z factorial. So arrangements star equals to z factorial of z zeros, um, and let's also take the modulus value. Okay, once I have the mod, then I can say this value, the arrangement, the overall arrangement equals to arrangements times arrangements, and let's take the mod. Okay, so once I have calculated all the possible arrangements for every block, then I can go from I mean there is one more catch here. This r should be minimum of n comma this value, right? Because it can't go above n, so that might give me an error if I don't rectify this here. And now answer is equals to answer plus the choices that I have times the arrangement that I got. And let's also take mod again and mod again. Yeah, let's change the input. And this is the expected output. Let's run this and see if it is working. Okay, so we got a correct answer. Let's try to submit this and see if it is working. What? We are getting a runtime error. Why is that? I'm not sure why we are getting a runtime error. Okay, so maxn was 5v5 and this is going till +1 +1. I think this much is correct because it is a template code. I think r can also be 0 here. So let's say if r equals to 0, then return 1. Yeah. Are there any other cases, like if my r is less than 0, then return 0. In fact, this much is correct. A of n, this is okay. Have is if s dot find 0 not equals to s dot end, that means 0 was found, then have minus minus. This is good. Are they telling me what kind of error it is? No. This is tough. Like I'm not sure why this is happening. Okay, let's see. We have prefixes going from 1 to n plus 1 value, and this is like okay. L is going from L to this value, minimum of n comma, like r cannot go above n. Yeah. Next repetition of L is greater than r, then we are good. It can't be equal to, right? I mean, if it no, it can't be equal to. Then nums is equals to prefix of r minus L plus k minus 1. Should it be -1? Shouldn't it be something like n plus k only? Let me just run this and see. No, no, it should be n plus k minus 1. Okay, prefix r minus prefix l minus 1. L is going from, so it can be 0. Okay, wait a second. Okay, so let's continue debugging. I'm not sure why this is happening, but okay. Please turn it off at 1 to 10. I think. I mean, once the arrangements are 0, I don't really need to do anything. I can simply break out of this loop. I think the rest of the things seem fine to me. The mod value is correct. Yeah. Let's try to run this again. I'm not sure why this is giving me a wrong answer. To me, it looks correct. Let's just try to submit this again with the break statement only. I think it was because of the break statement. Yeah. Okay, so we got the correct answer. It was because of this break statement. I should have put that here. Sorry about that. Now, so I think I will stop now. So install till too far comfort, and if you have any doubts, you can put them in the comments. I will answer to them for sure. Now I will see you guys next time. Thank you.